That's the way every day goes. Every time we've no control. If the sky is pink and wide, if the ground.
Yeah, what's wrong? You look so stressed. I really don't get MAT222 anymore. I just got my test result. My mark are really low. Look at this. I just got 10 over 3. That's so bad.
Oh, it's okay, Tia. I also improve. MAT222 is
Yes, I agree. I think we need to exercise a lot to get higher marks.
But which topic do you lose your mark the most?
The topic I lost many marks most is logical implication. I understand it's P then Q, but when the question involves arguments and conclusion, I get lost.
Oh, especially the rules of inference, right?
Yes, like modus ponens and modus ponens. During the test, I couldn't tell which one should I use. Like when I opened the paper, I never find it.
it's okay. Failure is not the end. Let's go through every logical implication topic together and learn its conclusion to understand it.
Let's go!
Hello everyone, in this video, I will explain the introduction to logical implication. Let P and Q be propositions. The proposition if P then Q, which is written as P implies Q, is called an implication or conditional statement. In this statement, P is the hypothesis, also known as the premise. Q is the conclusion or the consequence. Now, let's look at an example. If the sky is clear, then we will be able to see the stars. Here, P is represent the sky is clear, and Q represent we will be able to see the stars. Next, we refer to the truth table for P implies Q. As shown on the slide, from the truth table, we can see the P implies Q is false only when P is true and Q is false. In all other cases, the implication is true. Now, let's look at case 1. If the sky is not clear, then we will be able to see the stars. In this case, if P is false and Q is true. According to the truth table, when P is false and Q is true, the statement P implies Q is true. Lastly, logical implication can be expressed in several different ways, such as if P then Q, P implies Q, P is sufficient for Q, and Q is necessary for P. Even though the wording is different, all the statements have the same logical meaning. That's all for the introduction to logical implication. Next, I will explain valid and invalid arguments. An argument is said to be valid if, whenever the premises are true, the conclusion must also be true. On the other hand, an argument is invalid if it is possible for the premises to be true, but the conclusion is false. Now, let's look at the general form of an argument. We have statement A and B as the premises, and statement C as the conclusion. The symbol with 3 dots means therefore, so we read it as A and B, therefore C. One way to show that an argument is valid is to show that the implication from the premises to the conclusion is a tautology. In symbols, this means if P1 and P2 and up to Pn imply Q is always true, and then the argument is valid. Lastly, let's look at the symbol used. The symbol with the double arrow means logically implies. The cross arrow symbols mean does not logically imply. So, these symbols help us determine whether an argument is logically valid or invalid. That's all for valid and invalid arguments. Thank you.
So next, I will proceed with content of our topic. The rules of inference are indispensable tools in logic, serving to derive valid conclusions from premises through logical implication. They form the backbone of deductive reasoning by showing how a conclusion necessarily follows when the premises are true. Widely used in fields such as mathematics, computer science, and philosophy. These rules ensure that arguments involving implications are logically sound and consistent. By applying principles such as modus ponens, modus tollens, and syllogism, we can construct and analyze arguments with a high degree of clarity and precision. Therefore, understanding rules of inference is essential for anyone engaged in logical analysis and critical thinking.
Now, we move to the techniques for law of inference. So first, we have modus ponens. Number 2, modus tollens. Number 3, syllogism. Number 4, disjunctive syllogism. Number 5, contradiction. Next, for number 6, we have addition. Number 7, proof by case. Number 8, dilemma. Number 9, simplification. And lastly, conjunction.
So I will explain the example question of rule of inference. Consider the following argument. If Shahmi is not studying or is lazy on Saturday, then he will hang out with his friend. If Shahmi hang out with his friend, then he will watch cinema or play bowling. If Shahmi is play bowling, then he will eat hot pot. Shahmi did not watch cinema and did not eat hot pot. Therefore, Shahmi studied on Saturday. First, use variable P, Q, R, S, T, and U to represent the 5 primitive statements given in argument. 2. Rewrite the argument in 1 in symbolic form. Solution of question 1. Use variable P, Q, R, S, T, and U to represent the 5 primitive statements given in the arguments. The solution is for variable Q, the statement is Shahmi studied on Saturday. Variable Q, Shahmi was lazy on Saturday. Variable R, Shahmi hang out with his friend. Variable S, Shahmi played bowling. Variable T, Shahmi watched a movie. Variable U, and the statement is Shahmi ate hot pot. The solution of question 2, rewrite the argument in 1 in symbolic form. The solution is not P or Q in a bracket implies R. R implies S or T in a bracket. T implies U, not S, and not U. So the conclusion is P.
Let's move for example 2. The question asks us to construct the truth table to prove the validity of the argument if P is true. Since we have 6 variables for this case, we cannot construct the full table with 64 rows. So we do a shortened table. We know that our conclusion is true, so our premise also need to be all true. For premise 1, when our P is true, then negation P is false. Make sure premise 1 is true, our Q is false, so that negation P or Q is false. Our R also false, so that negation P or Q implies R is true. To make sure premise 2 is true, our S and T have the same truth value, which is false. So when S or T, the answer will be false. We know that our R is false. We can say that R implies S or T is true. For premise 3, our U is false, and we also know that our T is false. So we get T implies U is true. Last, for premise 4, negation S is true. Negation U also true. So negation S and negation U is true. So we can conclude that when premise 1 and premise 2 and premise 3 and premise 4 is true, the conclusion is also true. Therefore, the argument is valid.
So next, I will proceed with example 3, which is about proving the validity of an argument using the rules of inference. So for question 1, given if not P or Q, then R as premise 1, if R then S or T as premise 2, if T then U as premise 3, not P and not U as premise 4, therefore P as conclusion. Next, for the solution parts, firstly, we need to list all of the premises given. Then we will proceed with premise 5. From premise 4, which is negation S and negation U, we use simplification to take one part of a conjunction, so we obtain negation U. Next, for premise 6, from premise 3 and 4, we use modest tolerance. Since T implies U and negation U is true, we can conclude premise 6 as negation T. Now we proceed with premise 7. From premise 2, we use conditional identity to rewrite the implication as negation R or open bracket S or T close bracket. Next, for premise 8, from premise 7, we use associative law to rearrange the bracket without changing the meaning. So we obtain open bracket R or S close bracket or T. Then for premise 9, we use disjunctive syllogism on premise 8 and 6. Since T is false, it can be eliminated and leaving negation R or S. Next, proceed with premise 10. From premise 9, we use conditional identity to rewrite it as an implication, which is R implies S. Next, for premise 11, we apply syllogism on premise 1 and 10, which allows us to change the implication. So we will get open bracket or Q close bracket implies S. For premise 12, again from premise 4, we use simplification to extract the other part of conjunction, which is negation S. Next, for premise 13, we apply modest tolerance on premise 11 and 12. Since S is false, we conclude that negation open bracket P or Q close bracket. Then, for premise 14, we will use De Morgan's law and double negation on premise 13. So, simplify, we will get P and negation Q. Lastly, for premise 15, we use simplification on premise 14 to conclude P. So, since the conclusion P is derived logically from the given premises using valid rules of inference, the argument is valid.
Finally, I get it about this topic, logically implication. So now, I will explain the conclusion about this topic.
In conclusion, logical implication is a key concept in reasoning and problem solving. It helps us to understand the relationship between conditions and outcomes, forming the foundation for building and analyzing arguments. We have looked at how arguments are structured with premises leading to conclusion, how rules of inference guide us in reaching logical outcomes. Using truth table and recognizing tautologies, we can evaluate the validity of arguments in a clear and systematic way. The examples we covered show how these ideas are not only theoretical but also highly practical. Thus, understanding logical implication, argument rule of inference is essential for sharpening our reasoning skills, whether we are dealing with abstract problems or real-world challenges.
Makes it hard.